Moving on. Here's the next question, which says a plank of mass 20 kg is pulled with a rope up the slope inclined at 15 degree to the horizontal. So here's the 15 degree angle. Here's the plank. Okay, it's 20 kgs. So let's now resolve the weight components. One should be in this direction, which is always the cos component, mg cos theta. So 20 times 10, 200, cos 15. And this one would be mg sine theta, 200 sine 15. Weight has been resolved. फिर क्या कहा है? The slope is inclined at, the rope is inclined at 30 degree to the horizontal as shown in the diagram. Acha ji. So now they're saying that there's a rope acting at 30 degree, but it's not acting at 30 degree to the inclined surface. This is not what it's saying. It's saying it's acting at 30 degree to the horizontal. So they've actually made the question harder. Ab ye jo 30 degree angle and it's like, oops. Just a second. This was the mass. This was the inclined surface. And this was the rope acting at 30 degree with the horizontal. So this is the 30 degree angle. Okay, so they've actually made the question slightly harder than it was supposed to be. Usually हमारे साथ क्या कर रहे होते हैं हम कि यूं हमारे पास mass होता है और जो force होती है ना उसका जो angle होता है वो inclined surface के parallel होता है. These two lines are parallel. So that's when you do this. This is f sine theta and this is f cos theta. But now you don't have that angle. जो theta होता है ना, to resolve the force, that needs to be parallel to the surface जिस पे movement हो रही है, not the horizontal surface. So अब you have to see कि 30 degree तो horizontal के साथ है. What's the actual theta that we need? What is this theta? We need this theta. This one. So that we can resolve this force into its horizontal and vertical components. अब ये simply क्या होगा कि this is 15 degrees. This one. Right? And it's an angle between the slope and the horizontal surface, right? This 15 degree is an angle between the horizontal surface and the slope. This is 50. Notice that this is also the same angle. It's between the horizontal, ये भी horizontal है, ये भी horizontal था, right? And this is the slope. And this is also parallel to the slope, this movement or this vector. So this will also be 15 degrees. So these two angles are always the same. Okay, so 15 degree angle of inclination here. So there's a 15 degree angle over there as well. That means the remaining angles that's left of the 30 degree is 15 degree as well. 30 minus 15 is 15 degree. So जो हमारा targeted angle है, जो हमें चाहिए to resolve the force component is actually that upper 15 degree. So let me redraw the figure. You have an inclined surface, inclined at 15 degrees. You have a mass. You have a force. And the angle that the force is making parallel to the plane of motion is 15 degrees, not 30 degrees. Ye 15 degree hoga. Okay. So now you can resolve the force. Do we have the force? No, it's just the tension. It says tension. So I'm calling it T. So this would be T opposite है, so t sine 15. And this one should be t cos 15. Then there were the weight components. This one was 200 cos 15. And this one was 200 sine 15. In this question, there's a contact. So there must be a normal contact force acting perpendicular to the contact. So here's R. What else is mentioned in the question? Achha, nothing else so far. There is not a mention of friction so far. So I'm not drawing friction. Secondly, I don't know कि object ऊपर जा रहा है या नीचे जा रहा है. So depends on that. Friction अगर mentioned होती तो फिर हमें ये भी देखना पड़ता है कि object ऊपर जा रहा है तो friction downwards हम बनाते, या object नीचे फिसल रहा है तो फिर हम friction को ऊपर बनाते. ठीक है. So far they haven't mentioned any friction, तो हम भी नहीं figure में बनाते. Okay, let's see what the first part says. First part says, explain why the tension in the rope must certainly be greater than 53.6. Okay, so why would the tension be greater than 53.6? Let's see. What do we know so far? हमें इसकी वैल्यू पता है, ठीक है, और इसकी वैल्यू पता है. ठीक है, ये निकालते हैं. आई थिंक ये होगा 53.6. So let's see what is 200 sine 15. Can you find that out? Is that 53.6? मुझे ही करना पड़ेगा. 200 times sine 15. 51.7 आ रहा है. अच्छा नहीं, it is not. Just give me a second. ये आना चाहिए था. अच्छा, they talk about the tension. तो हमने tension find करनी है ना. I did not find the tension. Okay, so tension कैसे आएगी? Let's find the tension. What should I equate? Sorry?
Can we use the Pythagoras theorem to find that?
You will first need to form equations before you can use that. So what equations are you using? You need two equations. We can equate the up forces to the down forces. So you can say R, which we don't know, plus there's also another upward force, which is that parallel to R.
T sine 15.
Yeah, so R plus T sine 15 equals what?
200 cos 15.
Right, 200 cos 15. Can we find T from here? We can't, because we don't have R either. R पता होता तो हम तो T निकाल के दिखा देते कि look, this is T. So this is not helpful so far. How else can we find T? Let's equate T cos 15 with 200 sine 15. So T cos 15 should be equals to 200 sine 15 if it's at rest. If at rest. If it's not moving upwards, right? Only then we'll say that forward is equals to backwards. Otherwise, you will also have to use is equals to MA. Forward minus backward is equals to MA. But we're assuming that it's at rest so that we can find the T so far. This should be equals to 53.6. Can you guys confirm? So
Yes,
divided
now
by
it's equals to 3.6.
ठीक है. So that means that if the object is at rest, it's not moving upwards and it's not going downwards. If it stays where it is, then the tension should be 53.6 newtons. However, the question says that the plank is being pulled upwards. यही था ना question? Yeah, a plank of mass 20 kg is pulled with a rope up the slope. So अगर इस rope ने इस प्लैंक को अपवर्ड मूव करना है तो इसकी टेंशन ज्यादा होगी 53.6 से, क्योंकि 53.6 पे तो ये रेस्ट पे. Hence if plank has to be pulled upwards, then T needs to be greater than 53.6. Understood? हमने रेस्ट पे टेंशन निकाल के देखी. That comes out to be 53.6. So if the object has to be pulled upwards, तो फिर इस टेंशन की वैल्यू को बड़ा होना चाहिए, so that it's able to pull the object upwards. ठीक है? Now let's take a look at part B. Now it says the tension in the rope is 65 newtons, so it is greater. So that means it will move the object upwards. And the plank is moving at a constant speed. Okay, so अब T की value आ गई हमारे पास. Let me clear this. Or maybe I shouldn't have done that, but चलो अब कर दिया. Okay, so now the T is equals to 65. So I'm going to replace that. This is going to be 65 here. And this is going to be 65 here. Just write T equals 65. This is what we know for part B and C. Calculate the magnitude of the normal contact force. Okay, we need R. So let's use the equation we had written earlier, R plus now T is 65. 65 sine 15 should be equals to 200 cos 15. अब R निकाल के बताओ.
176.36.
Yeah, that is correct. 176.36 newtons. Okay. Then it says, find the magnitude of the frictional force. So if it has mentioned friction, we need to draw friction in the figure. Where should it point? Up the slope,
To the left,
down the slope? To
down.
the left. Okay. So since the object is being pulled upwards, we know that the friction opposes the motion. So it needs to be in this direction. We need to find this friction. So what equation should we use?
Forward force is equals to backward force.
Why not forward minus backward is equals to m? It's moving.
Because it's at constant speed.
Yes, exactly. Speed is constant. Acceleration is 0 since the speed is constant. Okay, so you use forward is equals to backwards. So you use 65 cos 15 equals 200 sine 15 plus friction, which comes out to be
11.0.
yeah, 11.0. Okay. This was question 14. Okay. Any questions so far, Azhar, Aisha, and Alia?
No.
No.
होने लगा है. Here we're going to talk about friction in greater detail. Friction. So what do we know about friction so far? We know that if an object is like this, and if it's moving in this direction, and then the friction should be in this direction if it's mentioned in the question. If it says there's a friction, then we know that it needs to point away in the opposite direction to the direction of motion. Then if the object is inclined, and let's say the object is moving upwards, then we know that the friction needs to point downwards. And similarly, if on an inclined surface, an object is moving downwards, then the friction should point upwards. So moving on, we might be using this formula to find friction. Fr, the friction equals to mu times R. Mu is something called the coefficient of friction. Its value depends upon the material of the surface. Value depends upon material of the surface. If the surface is smooth, that means that there's no friction. Smooth surface, a very shiny, clear surface, smooth surface has mu equals to 0, that is friction equals to 0. And if the surface is rough, it will have a certain value of mu, depending on the material of the surface. ज़्यादा rough surface है, bigger friction होगी, bigger mu होना चाहिए. कम rough surface है तो छोटी होगी mu की value, और because of that friction भी कम होगी. So mu is a coefficient of friction. या given होता है question में, या आपसे पूछा होता है. So whenever coefficient of friction is mentioned in the question, तो जो आप फिगर में फ्रिक्शन बनाओगे ना, उसकी जगह आप लिखोगे म्यू आर. So every time coefficient of friction is mentioned or this is mentioned, limiting equilibrium. Limiting equilibrium is mentioned, equilibrium. Then instead of friction, you'll use mu r. So most probably in the questions we'll be encountering after this, limiting equilibrium will be mentioned in the question. Limiting equilibrium means you don't just write friction. Instead of friction, you write mu times r, where mu is the coefficient of friction. Sometimes it's given in the question. Sometimes you will be asked to find it. And the R, you already know, is the normal contact force. Okay. Now, what is limiting equilibrium? I have the definition somewhere. Wait a second. Look for it. It is. Please write this down. Frictional force this is supposed to be frictional force cannot exceed a certain magnitude called limiting friction. Frictional force cannot exceed a certain magnitude called limiting friction. At the limiting friction or limiting equilibrium, at limiting friction or limiting equilibrium, they're almost similar. The object is about to move. And friction is equals to mu r. ठीक है अब what does it mean by all of these statements? Let me try explaining that to you. I hope you've written this. Anybody who's still noting this down? Okay. Let's say here's a surface or a surface when I calculator पढ़ा. Here's a calculator. Let's say कि आप इसको ना slightly touch कर रहे हो तो एक फोर्स लगा रहे हो इस पे ठीक है इनफैक्ट ये फोर्स ना मैं इस तरफ कर रही हूँ राइट साइड पे वैसे तो आप इस तरफ से कर रहे हो बट आई एम पॉइंटिंग दैट फोर्स इन दिस डायरेक्शन इट्स स्टिल पॉइंटिंग फॉरवर्ड ठीक है यू स्लाइटली टच दिस कैलकुलेटर यू आर एक्सर्टिंग सम फोर्स ऑन इट बट वो फोर्स इतनी कम है कि ये मूव ही नहीं कर रहा क्यों नहीं मूव कर रहा इवन दो you're applying a light force on it you have touched your finger you're slightly moving the finger forward but इतना ज्यादा नहीं वो मूव ही नहीं कर रहा क्यों नहीं मूव कर रहा क्योंकि फ्रिक्शन है आप जो फोर्स अप्लाई कर रहे हो ना उसको बैलेंस कर रहा है थ्रू फ्रिक्शन सरफेस फ्रिक्शन की वजह से so you're applying a small force let's say 1 Newton force I don't know ये कितनी फोर्स है एक्चुअली let's say आप 1 Newton फोर्स इस पे अप्लाई कर रहे हो ये नहीं मूव कर क्यों नहीं मूव कर रहा आप फोर्स तो अप्लाई कर रहे हो दैट इज बिकॉज उसको एक 1 Newton की फ्रिक्शन एनकाउंटर हो रही है दैट्स व्हाई इट्स नॉट मूविंग so when you're applying a 1 Newton force on the calculator but that force is so small that it's not moving why is it not moving because there's an opposing force of 1 Newton which is frictional force अब ना इस कैलकुलेटर पे फोर्स बढ़ाते हैं लेट्स से अब आप कर रहे हो 1.2 Newton की फोर्स थोड़ी सी ज्यादा कर दी फोर्स अब भी नहीं ऑब्जेक्ट मूव कर रहा क्यों नहीं मूव कर रहा? क्योंकि अब फ्रिक्शन उसको अभी भी काउंटर कर रही है। अब फ्रिक्शन ज्यादा हो गई, 1.2 न्यूटन की हो गई। सो फॉरवर्ड फोर्स एंड फ्रिक्शन देर इक्वल. So that's why even though you're exerting a force, but फ्रिक्शन भी ज्यादा हो गई, 1.2 न्यूटन की होगी, वो अभी भी नहीं ऑब्जेक्ट को मूव करने दे रही. ओके, अब क्या होगा कि इस फ्रिक्शन की एक लिमिट है. ये नहीं कि आप इस 20 न्यूटन की फोर्स लगाओगे और कैलकुलेटर को जोर से आगे फेंकोगे और फिर भी नहीं मूव करेगा. ऐसा नहीं होता. इवेंचुअली आफ्टर सर्टेन पॉइंट उसने मूव कर जाना है. अब व्हाट इज दैट थ्रेशहोल्ड ऑफ द फ्रिक्शन? फ्रिक्शन बढ़ती जाती है, बढ़ती जाती है, बट उसकी एक लिमिट है. दैट इज कॉल्ड लिमिटिंग फ्रिक्शन या लिमिटिंग इक्विलिब्रियम. ये जो फ्रिक्शन है ना, इसकी जो मैक्स वैल्यू है ना, मैक्स फ्रिक्शन इज इक्वल्स टू म्यू आर. सो अगर आप म्यू आर से ज्यादा फोर्स लगाओगे ना तो फिर ऑब्जेक्ट मूव करेगा. लेकिन अगर आप म्यू आर से कम फोर्स लगाओगे तो वो फ्रिक्शन भी उसी वैल्यू की आ जाती है. जिस जिस वैल्यू की फॉरवर्ड फोर्स है, फ्रिक्शन भी अपनी वही वैल्यू ले लेती है, तो वो ऑब्जेक्ट को मूव ही नहीं होने देती. लेकिन अगर आप उससे ज्यादा लिमिटिंग इक्विलिब्रियम से, लिमिटिंग फ्रिक्शन से ज्यादा फोर्स लगाओगे तो फिर फॉरवर्ड फोर्स ग्रेटर हो जाती है, फ्रिक्शन स्मॉलर हो जाती है और ऑब्जेक्ट मूव करने लग जाता है. ठीक है. सो limiting equilibrium or limiting friction is that maximum value of friction जिसके बाद ऑब्जेक्ट मूव करता है. उससे ज्यादा अगर फोर्स लगाई जाए तो ऑब्जेक्ट स्टार्ट्स टू मूव. तो जब लिमिटिंग इक्विलिब्रियम मेंशन होता है क्वेश्चन में, तो आपने फ्रिक्शन को एफ आर नहीं लिखना, आपने फ्रिक्शन को डायरेक्ट फिगर में म्यू आर लिखना. The coefficient of friction will be given to you in most of the cases, या कभी कभी वो बस अननोन कांस्टेंट होता है और आपने इसको फाइंड करना होता है. ठीक है. सो दैट इज द कॉन्सेप्ट ऑफ लिमिटिंग फ्रिक्शन एट लिमिटिंग इक्विलिब्रियम. लेट मी रिपीट. आप अगर थोड़ी फोर्स लगाओगे एक ऑब्जेक्ट पे तो वो उतनी ही फ्रिक्शन अप्लाई करेगा और वो ऑब्जेक्ट को मूव नहीं होने देगा. फिर आप थोड़ी सी ज्यादा फोर्स लगाओगे, अभी भी वो फोर्स म्यू आर से अगर आपने कम लगाई है तो फिर फ्रिक्शन वो न्यू फोर्स की वैल्यू ले लेगा और ऑब्जेक्ट को नहीं मूव करने देगा. वो फॉरवर्ड और बैकवर्ड बैलेंस हो रही है. लेकिन अगर आप एक फोर्स लगाते हो जो म्यू आर से बड़ी है तो फिर वो ऑब्जेक्ट मूव करेगा, क्योंकि फॉरवर्ड फोर्स बड़ी हो गई फ्रिक्शन से. फ्रिक्शन मैक्सिमम वैल्यू म्यू आर तक ले सकता है, उससे ज्यादा बढ़ नहीं सकता. तो जब म्यू आर फ्रिक्शन होती है ना, उसके बाद अगर आप थोड़ी सी भी उससे ज्यादा फोर्स लगा दो, एक्सर्ट कर दो, तो देन द ऑब्जेक्ट हैज टू मूव बिकॉज द फॉरवर्ड फोर्स बिकम्स ग्रेटर देन द फ्रिक्शनल फोर्स. इस पे क्वेश्चन करके देखो. Here's the question. A horizontal cable from a horizontal cable from a winch is attached to a small boat of mass 800 kgs. So here's a boat. Let me slightly zoom in. Okay. Boat. Okay. 800 kgs. That means 800,000 newtons is the weight, which rests on a horizontal ground. The coefficient of friction is 3/4. तो अब देखो mu mentioned है question में 3/4. That this is 3/4. So that means इधर ही आपको first hint ही मिल गई कि friction की जगह हमने use कर लेना होगा mu r. अगर limiting equilibrium mentioned है तो. Okay. The tension in the cable is increased in steps of 100 newtons. Acha, so the tension is also horizontal. There is no inclined angle here. So this is T. What is the friction force when the tension is 5900 newtons? Okay, case A here, that acha, friction should be in this direction, of course. It opposes the motion. Here's the movement. Rightward, so friction needs to be in the opposite direction. First case में कहा है, अच्छा, I should have also pointed the normal contact force. Of course, if there's contact, then there has to be a force normal to the contact, RBH figure में. Okay. In part A, it's asking कि when the tension is 5900 newtons, what's the friction? पहले तो हम देख लेते हैं maximum friction क्या होनी चाहिए. Maximum friction is equals to mu r. Mu is given in the question 3/4. What should be r in this question? r जो है उसके opposite a की force है, weight.
8,000.
So it needs to be 8,000. Yes. So in this case, r is simply equals to the weight. R equals mg in this setup. और कोई force नहीं है upward और downward direction में, क्योंकि कोई inclined force है ही नहीं जिसकी वजह से कोई components बन रहे. So R is simply 8,000. So maximum friction क्या है? Maximum friction would be 6,000 newtons. Okay. तो जब टेंशन 5900 न्यूटन्स की है, वही कैलकुलेटर वाला केस, क्या आप मैक्सिमम फ्रिक्शन से कम वैल्यू, अब कम फोर्स अप्लाई कर रहे हो. 5900 न्यूटन इज द टेंशन, तो फिर फ्रिक्शन भी सेम वैल्यू ले लेती है. फ्रिक्शन शुड ऑल्सो बी 5900 न्यूटन्स एंड इट विल नॉट लेट द ऑब्जेक्ट मूव, क्योंकि आपने जो फोर्स अप्लाई की है वो मैक्सिमम फ्रिक्शन से कम है. So the friction will not let you move the object. Since T is less than mu r, the limiting equilibrium friction. 5900 is less than 6,000. Object stays at rest. क्योंकि फ्रिक्शन भी अपनी वैल्यू 5900 न्यूटन्स ले लेती. So that's part A. Part B में the force increases to 6,000 newtons, but that is still equals to the maximum limit of friction. 6,000 newtons friction bhi ho gayi. So now in part B, the friction is also equals to 6,000 newtons because it's allowed to take that value. 6,000 तक friction जा सकती है. तो अगर आपने 6,000 न्यूटन की फोर्स अप्लाई की है तो फ्रिक्शन भी 6,000 न्यूटन की हो जाएगी. ऑब्जेक्ट इज स्टिल एट रेस्ट बट इट इज अबाउट टू मूव. थोड़ी सी भी अगर आपने 0.1 न्यूटन फोर्स भी बढ़ा दी तो अब ऑब्जेक्ट मूव कर लेगा, क्योंकि फ्रिक्शन 6,000 से ज्यादा नहीं हो सकता. ऑब्जेक्ट इज अबाउट टू मूव, स्टिल एट रेस्ट बट इट विल मूव आफ्टर दिस. Object is about to move. Okay. And lastly, the third case may the friction becomes greater than 6,000 newtons, अब आ गई 6,100 newtons. तो फ्रिक्शन अभी अपनी मैक्सिमम वैल्यू पे ही रहेगा, विच इज 6000 न्यूटन, उससे नहीं ज्यादा बढ़ सकता. So even though the tension is 6100 Newton, friction is not allowed to go beyond mu r. So it stays at 6000 Newtons, and object moves in the direction of tension, moves in direction of tension. That would be all for today. If you have any questions, please ask. Tomorrow, inshallah, we'll start with a few questions from the book on f is equals to mu r and inclined surfaces. और फिर हम इस टॉपिक की वर्कशीट स्टार्ट कर देंगे कल. ठीक है, see you guys tomorrow inshallah. अल्लाह हाफिज.
Allah Hafiz, ma'am.
No,